Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize, and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hello and welcome to Microsoft Azure Virtual Training Day course, Implement a Lakehouse with Microsoft Fabric. I'm Barbara Andrews, a Microsoft technical trainer at Microsoft, with over 5 years at the company and decades of experience working with data. I'm passionate about sharing my knowledge and helping others succeed. Feel free to connect with me on LinkedIn at linkedin.com/in/Barbara-Andrews-SoCal. This course is divided into 6 sessions across 2 parts. Part 1 starts with Session 1, where we will get an introduction to end-to-end analytics using Microsoft Fabric. In Session 2, we'll discuss how to get started with lakehouses in Microsoft Fabric. We'll wrap up with Session 3, which covers how to use Apache Spark in Microsoft Fabric. After Session 3, we begin Part 2 of the course, starting with Session 4, which covers how to work with Data Lake tables in Microsoft Fabric. In Session 5, we'll ingest data with Data Flows Gen 2 in Microsoft Fabric. Finally, we'll wrap up the course with Session 6, where we will use Data Factory pipelines in Microsoft Fabric. Here are some of our learning objectives in Session 1. First, I will discuss what Microsoft Fabric is, focusing in on its end-to-end analytic capabilities. I'll also highlight data teams and roles that use Microsoft Fabric. And lastly, I'll talk about how to enable Microsoft Fabric. Let's get started with Session 1. To start, you might be asking right now, what is Microsoft Fabric? It is a single, integrated, end-to-end analytics platform designed for all data professionals and organization decision makers to collaborate on your organization's data stored in one lake in the Delta Parquet format. It is a set of integrated SaaS, or software as a service, that can be used for extraction, transformation, and loading, or ETL, and for transforming and analyzing your organization's data. It is easily accessible by all Fabric services, workloads, or engines, with nothing to provision, nothing to architect, nothing to update. All you need to do to start is create your service by giving it a name. Microsoft maintains it, manages it, and scales it as needed behind the scenes and keeps it continuously updated. Let's focus now on some of the services or workloads or experiences under the hood of Microsoft Fabric. First, we have Power Query Online for both data ingestion and transformation through Dataflow Gen 2, and pipelines for ingestion, orchestration, and transformation using the Azure Data Factory. We will discuss this more in upcoming sections. Next, we have data engineering, which is based on Apache Spark. It is used for distributed high-performance processing and transformations at scale of any type of big data using Spark clusters and notebooks, while utilizing various Spark languages like PySpark or Spark SQL, to name a few. The Fabric Data Warehouse is a traditional data warehouse that uses structured data in tables for both exploration and querying of your data, along with the full T-SQL suite of statements that can be used. With data science, we bring Azure Machine Learning and Spark into Microsoft Fabric for model training on your data. Real-time analytics offers real-time streaming of large volumes of data that can be queried and analyzed as it streams into your event house or lakehouse or more sync destinations in Fabric. Lastly, Power BI is also included here to analyze your data and gain actionable insight for making critical business decisions through metrics, reports, and dashboards. Please note that all of these Fabric services, workloads, or experiences are built on OneLake. Storing all your data in OneLake can give your organization one single source of truth for all of your data, for collaboration with all your data and business professionals, and it can get rid of the data silos located throughout your organization that might be managed by different owners and may not have consistent security or governance. In Fabric, compute and storage are two separate components, giving us the ability to scale them separately as needed to accommodate your organizational workload needs. The business model or semantic model is also created automatically from the relationships that Fabric finds in your ingested data in OneLake, or you can create the relationship manually. As an example, data that you've uploaded into the data warehouse or lakehouse can be used by both. You just have to reference it. No need to move or duplicate your data. OneLake is a single unified tenant-wide SaaS storage system to store any type of file, which makes it perfect to hold structured, unstructured, and semi-structured data that is very common with today's diverse data that may or may not be in a table format and more likely to be in a comma delimited image, streaming, or social media format. Please note that all of the services in Fabric automatically store data in OneLake in the Delta Parquet format without any extra configuration. So there's nothing to provision, nothing to set up, and nothing to manage with OneLake. Just remember to ingest your data into OneLake using, for example, data pipelines, Dataflow Gen 2, mirroring, shortcuts, uploading, or many more other ways. OneLake is built on top of the Azure Data Lake Storage Gen 2, which makes it very easy to be able to search your data in this hierarchical format. As a matter of fact, you can download OneLake File Explorer for Windows to check its structure and use it directly from File Explorer in Windows. It has been called the OneDrive for your organization's data. Microsoft Fabric makes it easier for data and business professionals to collaborate because of its single integrated SaaS end-to-end analytical environment. The roles on your data team will likely look different depending on your organization, but generally speaking, data engineers are responsible for building, managing, and securing the data pipelines that ingest, transform, and store data from various sources. They use tools such as Data Factory, Data Warehouse, data engineering, like the Lakehouse and the real-time intelligence, to create scalable and reliable data solutions. Analytics engineers are responsible for designing, developing, and testing the data models and analytic logic that powers the data products and insights. They use tools such as Data Factory, Data Warehouse, data engineering, like the Lakehouse and Power BI, to create and deploy analytics solutions. Data scientists are responsible for applying advanced statistical and machine learning techniques to discover patterns, trends, and predictions from data. They use tools such as the Azure Machine Learning and the Data Science Experience to create and operationalize data science models and applications. Data analysts are responsible for exploring, analyzing, and visualizing data to answer business questions and generate insights. They use tools such as Power BI and Excel to create and share interactive reports and dashboards. And lastly, business decision makers are responsible for using data and insights to make informed and strategic decisions that drive business outcomes. They use tools such as Power BI, Excel, Power Apps, and Power Automate to consume and act on data and insights from various sources and scenarios. All roles should act as data stewards because data needs to be properly managed, governed, and used to drive business value and, of course, innovation. To enable Microsoft Fabric, it must be turned on by a Fabric admin or a Power Platform admin or a Microsoft 365 admin at the tenant level. To use Microsoft Fabric, you must have a workspace that has been assigned either a premium capacity or a Fabric license. To recap this section, we answered the burning questions of what is Fabric, your single integrated end-to-end analytics platform for collaboration. We also defined each of the Fabric workloads: Data Factory, Data Engineering, Data Warehouse, Data Science, Real-Time Intelligence, and Power BI, along with some foundational information about OneLake as the OneDrive for your organizational data. We also explored the common data professional roles and the workloads and tools that they commonly use. Lastly, we talked about how to enable Microsoft Fabric in your tenant, along with the need to assign the premium per capacity or Fabric license to your workspace in order to use Fabric. This concludes session 1. We will take a quick 10-minute break before starting with session 2. Get started with Lakehouses in Microsoft Fabric. Welcome back from the break. In this session, we will define what the Microsoft Fabric Lakehouse is, focus on how to use the Lakehouse to explore, transform, and visualize data, while highlighting some of its foundational features and capabilities. Let's get started with session 2. What is a Lakehouse, you might be asking? It's data architecture in Microsoft Fabric that is used for storing, transforming, managing, and analyzing any type of data, all in a single location, formatted by default in the Delta Parquet format. With the Lakehouse, you can perform transformations, data analysis, and exploration. To perform transformations in the Lakehouse, we use Spark, especially to process large-scale data. Stay tuned for a later section on Spark for more details. For data analysis and exploration, a read-only SQL endpoint is created automatically for us when we create a Lakehouse. Another key element of the Lakehouse is that it supports ACID, atomicity, consistency, isolation, and durability. Transactions through Delta Lake formatted tables, which we will also explore a little later on in this section. It also can be scaled automatically and provides high availability and disaster recovery, along with supporting some of the latest AI technology with machine learning and predictive modeling analytics. The Lakehouse merges OneLake storage flexibility with the data warehouse analytics for a comprehensive analytics on a single SaaS platform. Notice OneLake on the left providing scalable and distributed file storage and its ability to support any type of data, structured, unstructured, or semi-structured, coupled with the data warehouse and its relational modeling and T-SQL querying capabilities. It provides a centralized location for data engineers, data scientists, and data analysts to access and utilize data. In Microsoft Fabric, you can create and configure a Lakehouse in the data engineering experience in any Fabric workspace. After creating a Lakehouse, you can load data in any common format from various sources, including local files, databases, or APIs. Here we see Fabric items that have been created when you create a Lakehouse. The creation of a single Lakehouse produces 3 named items in the Fabric-enabled workspace. A Lakehouse provides storage and metadata where you interact with files, folders, and table data as shown here. The SQL Analytics endpoint is a read-only option through which you can connect and query data using T-SQL. It has a familiar SQL Server Management Studio or SSMS-like interface structure as shown here on the left. A semantic model is an automatically created data model based on the tables in the Lakehouse. Power BI reports can also be built from the semantic model by clicking on Create a Report as shown here on the right. Under the visual, this data or even be shared with others. Loading or ingesting data into the Lakehouse is the first step in your extraction, transformation, and load or ETL process. You can use any of the following methods to bring data into the Lakehouse. Upload local files or import and transform data using Power Query Online or Dataflow Gen 2. You can also use notebooks with Apache Spark to ingest, transform, and load data, or you can use even Data Factory pipelines with the copy data activity. This data can then be loaded directly into files or tables. Consider your data loading pattern when ingesting data to determine if you should load all raw data or as files before processing or staging tables. More on this to come in later sections. Another way to access and use data in Fabric is to use shortcuts. What are shortcuts? Shortcuts are a great way to integrate data into your Lakehouse while keeping it stored in an external storage. Shortcuts are objects in a Lakehouse that point to other storage locations that can be internal, like pointing to another Lakehouse, warehouse, KQL database, or dataset, or external, pointing to maybe something like Azure Data Lake Storage Gen 2, or Dataverse, or a competitor's cloud. The shortcut is a symbolic link that is independent from the target. So if you delete a shortcut, the target remains unaffected. However, if you move, rename, or delete a target, the shortcut can break. Note that source, data permissions, and credentials are all managed by OneLake. When accessing data through a shortcut to another OneLake location, the identity of the calling user will be utilized to authorize access to the data in the target path of that shortcut. The user must have permission in the target location to read the data. Shortcuts can be created in both lakehouses and KQL databases and appear as a folder in the lake. This allows Spark, SQL, real-time intelligence, and analysis services to all utilize shortcuts when querying data. Now let's look at some of the tools and techniques to explore, transform, and visualize data in the Lakehouse. One of our foundational options for working with the Lakehouse is Apache Spark. It uses Spark pools that execute our Spark code in a notebook, or for Spark job definitions that process data in your Lakehouse. It uses a number of Spark languages like Scala, which is based on Java, PySpark, which is a variant of Python, Spark SQL, like T-SQL, and Spark R, to name a few. More on Apache Spark in an upcoming section. One of the main ways to work with Spark is through a notebook. Notebooks provide an interactive coding interface to read, transform, and write directly to the Lakehouse as tables and/or as files. By contrast, Spark jobs are non-interactive coding interfaces that we can use to run on demand or on a schedule with a pre-created script. Another option we can use is SQL Analytics endpoints. These will build automatically when you create a Lakehouse, and it's designed for us to be able to run T-SQL statements to query, filter, aggregate, and explore tables in the Lakehouse. Dataflow Gen 2 can be used for ingestion and transformation, and it is set up in Power Query Online in Fabric. Pipelines are used to orchestrate activities for more complex extraction, transformation, and loading. More on both those tools a little later on. Lastly, visualizing data in the Lakehouse, Warehouse, or in Fabric can be done in Power BI, as you can easily create a report from the data that you've uploaded into OneLake. Now, let me take some time to show you a great exercise. Create and ingest data with Microsoft Fabric Lakehouse.
And let's start our first lab. First, I'm going to navigate out to app.fabric.microsoft.com. And once there, I'm going to go into Workspaces and create a new workspace. I'm going to call this workspace really anything I want to call it, but I'm going to call it DP700 Lab 1. And I'm going to set this up. And this is an important point. I'm going to set this up with my Fabric capacity. So if I don't have a Fabric capacity, I could also use a 60-day trial. I would have to first get that trial before I could select it. But I have the Fabric capacity, so I'm going to select that. And then I'm going to make certain that I have it backed up into the capacity that I've created in Azure. So I have a Fabric capacity that I can use. And again, if you don't have that, you can use the trial. You will first have to get that trial for 60 days. And you can get that simply by going to our app.fabric.microsoft.com and selecting your profile picture up at the top there and choosing Start Trial. However, I'm going to use my Fabric capacity here. I'm going to apply it. And once I do that, what you will see is I have currently nothing in my workspace. I'm going to drag this up just a little bit so I have a little more space to work here. Then what I'm going to do is I'm going to go ahead and create a Lakehouse. So I'm going to click on New Item, and I'm going to look through many items here to see if I can find the Lakehouse. There is a Get Data section that we'll see a little bit later in some of our labs here. But we're going to start off in this area right here, Store Data. And there's an option right there for the Lakehouse. So this is one way for me to come into it. And then I'm going to call this Lakehouse DP700 Lab 1. and I'll go ahead and create that. Now it's going to take it just a bit to do its creation. It'll create it with two main folders that we'll be using. One is tables and one is files. And what we'll note about those two tables is that there are a number of options with it. One is that the tables folder will ultimately contain our SQL semantics here that we can query against it. And it will have inside of it usually our Delta Lake files or our Delta Lake table. And the files folder will normally have data that we are ingesting, files that will be stored here that aren't associated with the Delta tables up in the tables folder. And we could also, of course, create some shortcuts here, which we'll do in a little bit too. So what we're going to do first is we could go through and get data from a lot of places. As you can see, there's an upload files here that we can use to get data off of our local system. There's also a start option here with sample data that you can upload. You can create a shortcut, which we'll see that shortly. You can also upload by creating a new, or you could use an existing data flow Gen 2, and then same thing with the pipeline. So what I'm going to do is I'm going to create a little bit of structure here before we upload some of our files. And what I'm going to do is I'm going to create some folders. So I'm going to go into the files folder there. I'm going to click on the ellipses, and I'm going to go ahead and select the option to create a new subfolder here. I'm going to call it data. And let me go ahead and create that. Then what I'm going to do is I'm going to upload into that data folder. Now, in order to do an upload, we do have the sales CSV file that is available for you to download. And I can download it simply by putting in that URL right there, saving the CSV file to my local system, and trying to remember where I put it so I can pull it up. But I'm going to use this CSV file here off of this web address. Then what I'm going to do is go out and find that information. So I'm going to go ahead and pull this data into the data folder. I'm going to go and click on the ellipses, choose upload, and then upload files. And then I'm going to go find my files here off the drive. So I can find it right here. You can see where I placed it. I'm going to pull that in, and then I'm going to upload. So that will take just a little bit. Notice it's about 3 megs. And when I click on data here, you should see the sales CSV file. And if I click on that sales CSV file, you should see what it looks like. And it looks very similar to what we saw off the URL that we saw just a moment ago, the GitHub option there. So we can see what it looks like. I'm going to go back in to that sales file here, and we can do a little bit more exploration on it. You can see that it's a CSV file, but I could also take that CSV file and I can do a few more things with it. One of which is creating a table from it. So it's a CSV file, a comma separated value file, and that would easily convert into a table. And I can do it from right here, simply by clicking the ellipses and choosing load to tables, selecting the table. And notice when I do that, it gives it a name of sales. And I can change that if I'd like. I could also tell it the separator that's being used between the fields. I could have it use the header for the column names. And I kind of like how this is already set up here. So I'm just going to click on load. And when I do that, it's going to take it a moment, but it's going to add that table from that CSV file as a Delta table into the tables section. And we'll see that momentarily here. So we'll give it just a moment. There it is right there. And then I could go in and look at it if I'd like. There's the sales table, and it's going to be formatted as a table as opposed to being formatted as a CSV file. And it looks pretty good. Okay, so that looks good. So you can see that table has a little triangle against it. It's a Delta table. If I expand it, you can also see that we can have note of all the fields that are there and the data types. So that could be helpful. So we saw at least one way to pull data in to our Lakehouse, we will also take a closer look too at the fact that you can create a shortcut. So before I do that, I'm going to go down here into my data area. And what I'm going to do is I'm going to click on this again, and I'm going to choose New Shortcut. And right here, you can see other ways that you can connect to data. The shortcuts would leave the data where it's at, and we're going to use the shortcut to be able to use it here inside of Fabric. And there's all sorts of shortcuts you can work with, some that are internal in one lake, like a lakehouse, warehouse, or data set, and others that are external, maybe our Azure Data Lake Storage Gen 2 or Dataverse or other cloud options. As you can see, we can get connected. So a lot of ways to work with it. So you can see a lot of ways to ingest. And then, we have our table here. We have our data out here, so our CSV file. And then what I can show you too is maybe a little bit more about that table. So what I'm going to do is I'm going to click on that table, and I'm going to choose the ellipses here, and I'm going to see if I can view the files. And when you do that, you can see a little bit more about how this is a Delta table. It has the Parquet format that it's stored in, as you can see there. And then it also has this other folder, the Delta log, which is used, since it's a Delta table, this is used to hold changes to the table. So you can see some more information there that might be helpful. Now what I'd like to do is we're currently looking at the Lakehouse view, but the Lakehouse actually has two views. And you can see a little bit of it talked about right here. As SQL Analytics endpoint for SQL querying is also available, but we have to get into the right view to do it. So I'm here in the Lakehouse. I ingested data. I turned the data into a table. Now what I want to do is I want to go and see that SQL endpoint and see if I can query some of this data. So let me try clicking that one more time. And once I do that, it gives me another view. Now, this view is going to be a little bit different than maybe what we're used to seeing here in a Lakehouse per se. It is an option that looks very similar to our SQL Server Management Studio. And in here, what you'll see is I can find my table that I was using earlier. It's here under DBO and tables, and there it is right there. And I can click back on it and give it a moment here to give me a preview. And I have other options that are here, as you can tell. I can work with views, functions, stored procedures here. There are some query insight tables that are also here. And we will take a look at the model layouts in a bit here. But what I'd like to do right now is see if we can run a query. So you can do this a couple different ways. One way is I'm going to go up to New SQL Query, and I can use a visual one. I can also run a query in a notebook, and you can also do it through just writing pure T-SQL. So I have a snippets file that you can use to get this text that I'm going to paste in right now. And that snippets file is from right here. And you can see the path on that, so you can download that from our GitHub there. I'm going to go back to Fabric. And when I click in Fabric, again, what I'm going to do is I'm going to go ahead and run this query. Now, as you can see, this query does a number of things here. This query is going to go ahead and select the item field and also create a new field called revenue that is going to multiply quantity times unit price by summing it. So summing quantity times unit price. And it's getting all this information from our sales table. It's going to group by item, and then it's going to order by revenue descending. So you can kind of see the results there. And you can, if you need to, move this out to Excel. You can also try to go in and do a visual results, so that's another option. You can copy it too if you'd like to do that. A lot of ways to copy that and use it other places. You could save it as a view if you'd like to do that. That's a good option, especially if you want to run it over and over. And then you'll find it here in the views. The other thing that I think is an excellent option is this explain query. So I could click on that. It's going to take it a moment and it's going to explain this query to me line by line. Notice I can still run it the way it is because all the comments that it added in are added with the double dash there so that we can tell that it's going to just be a comment and not run by our query engine here. And then had we had errors in this, you'll also see another option that can help you fix those errors. So a lot of good stuff we've added to this. We also have an option, instead of going through and writing the query out, what if we were to go in and do a visual query? So the visual query is an excellent option. And to do that, you have to work with this design surface right here. So I'm going to go find my sales table. And there's a little bit of a trick to this. I know sometimes people have a little bit of a hard time doing this, where they just click and drag very quickly. What you want to do to make this work is you want to click hold and then drag and then release. If you do it too fast, where you're just clicking and dragging across and not really getting a hold of it when it's in the list there, sometimes it's not going to drag to the design surface. So notice here when we've dragged it to the design surface, you can see the result of it down below. You can see that we could save it as a table if we wanted to do that. That could be handy if we needed another table. Maybe we do a modification in the query here and then save that results as a table. That would be handy. Maybe we could download it to Excel. Maybe we want to visualize it right now. So we will visualize it at the end, but we'll do it with Power BI, which will be fun. So here, what I'm going to do is I'm going to make a little bit of a change to the fields that I have available down here. So I'm going to click this plus sign. And as you go through the list here, you can see a number of things that you can do to write this query visually. One of the options is I'm going to choose columns. And then I'm going to go through the list. I'm only going to select a couple here. So what I want it to do is I want it to select the sales order number and then also the sales order line number. So I'm going to select both of those. I'm going to click OK. And then we're going to see our result set reduced down there. So now I have that. And I have over 99 records. And I also have 2 fields, as you can see. So now I'm going to add a little bit more to this, and I'm going to go into transform, and I'm going to have it transform using group by, kind of a fun way to use group by here. And I'm going to choose the option here off of basic. There is an advanced option too that you can use, but basic is the one we'll need for this. And I'm going to have it group by our sales order number. And I want it to create a new field that's going to be called line items when we do our group by order number. And then I want it to, for the operation here, to count distinct values. So let's do that. And this distinct value column is going to be our order line number. So I'm just going to check this very quickly. I'm going to go ahead and click OK. And now you'll see hopefully a result here that gives us what we're looking for, grouping by order line number, the count of distinct values. And you can see that right there. So now we have still a lot of records here and 2 fields. And I can scroll down and see the count for each of those sales order numbers there if I need to do that. It looks like it's still processing. We're now up to 299 records plus here, as you can tell. So now that I have this query run, what I'm going to do is I could go out and make a report from this. So I could also use the options we mentioned here earlier. But what I'd like to do before I make the report is go check out what the model layout looks like. So I'm going to go out to the model layout, and you're going to see some of the tables that are here in our model. Now, some of these tables we may not remember ever adding. A lot of these tables are created behind the scenes to give us information about what we've run historically, and how frequently they run. And we have a lot of options there that we can query these directly. We can also go into query activity and see some of this information already kind of broken out for us. But what I'm going to do is I'm going to use that sales table. That is the table that I would like to query from. So I'm going to go over to the reporting tab, and I'm going to click on new report. And when I do that, let me hit continue. And it will take it a moment here. And it should push me in to my favorite, Power BI. Hopefully it's your favorite too. It's a really good tool. And what we'll see is we have our sales table there. And what I'd like to do is I'd like to use that sales table as a way to create a visual. So the visual that I'm going to select is going to be my clustered bar chart. So I can do that. I'm going to select item. I'm going to select quantity. And I could drag this out to take a look at it. Notice it gives us kind of a default view there. And I have to scroll down and see all the records. But what I want to do is turn this into a clustered bar chart. So let's take a look at that. That doesn't look too bad there. It looks pretty nice. And I can drag this out, as you saw, make changes to it. So there you have it. We went all the way through and we created our lakehouse. We uploaded data into the lakehouse. Then we queried the lakehouse and created a report. So let me go back to my workspace and I want to save that too. Let me save the report. Forgot to do that. So I'm going to call this DP 700 report. And let me save that. So the report has been saved. If I want to go to my workspace, I'm going to have to click that and get into it. There we are. So you can see the items we've created here. We made the lakehouse. We made the report. We used that SQL endpoint too that you can see right there. And then you can see there's also a model that has sales inside it. Thank you for joining me. I hope you enjoyed this presentation.
To recap this section, we defined what is a lakehouse as the bringing together of data lake and a data warehouse, supporting large amounts of any type of data for storage, analysis, transformations, and reporting. We also looked at the Lakehouse Explorer with its files and tables folders for storing any type of data and Delta tables. We explored the SQL analytic endpoint for querying our Delta tables, and we took a closer look at our semantic model or our data set to get more details to visualize and share data. This concludes session 2. We will take a quick 10-minute break before starting with session 3. Use Apache Spark and Microsoft Fabric. Welcome back from break. In this session, we're going to talk about some of the key elements in the Apache Spark architecture, how to configure a Spark cluster, Spark use cases, and how to use Spark to process, analyze, and visualize data. Let's get started with session 3. The process of distributing tasks and collating results is all handled for you by Spark. Spark can run code written in a wide range of languages, including Java, Scala, Spark R, Spark SQL, and PySpark. In practice, most data engineering and analytical workloads are usually accomplished using a combination of PySpark and Spark SQL. A Spark pool consists of compute nodes that distribute data processing tasks. As shown in the diagram, a Spark pool contains two kinds of nodes. One, a head node in a Spark pool coordinates distributed processes through a driver program. And two, the pool includes multiple worker nodes on which executor processes perform the actual data processing tasks. The Spark pool uses this distributed compute architecture to access and process data in a compatible data store, like a Data Lakehouse based on OneLake. Microsoft Fabric provides a starter pool for each workspace, enabling Spark jobs to be started and run quickly with minimal setup and configuration. You can configure the starter pool to optimize the nodes it contains in accordance with your specific workload needs or cost constraints. Note that administrators can manage Spark settings at a Fabric capacity level, enabling them to restrict and override Spark settings in workspaces within an organization. As mentioned earlier, Apache Spark is often used in conjunction with data lake architecture to process and analyze large volumes of data stored in the data lake. Use Spark and Fabric to transforming data or even to build a machine learning model. You submit a data processing job in the form of some code that initiates a driver program, which uses a cluster management object called a Spark context to manage the distribution of processing in the Spark cluster. In most cases, these details are abstracted, and you simply just need to write the code required to perform the data operations you need. In Microsoft Fabric, each workspace is assigned a Spark cluster. An administrator can manage settings for the Spark cluster in the Data Engineering Science section of the workspace settings as shown here. The Spark open source ecosystem includes a wide selection of code libraries for common and sometimes very specialized tasks. Since a great deal of Spark's processing is performed using PySpark, the huge range of Python libraries ensures that there's usually a library to help with whatever the task is that you need to perform. The Spark open source ecosystem includes multiple versions of the Spark runtime, which determines the version of Apache Spark, Delta Lake, Python, and other core software components that are installed. Additionally, within a runtime, you can install and use a wide selection of code libraries for common tasks. In some cases, organizations may need to define multiple environments to support a diverse range of data processing tasks. Each environment defines a specific runtime version as well as the libraries that must be installed to perform specific operations. Data engineers and scientists can then select which environment they want to use with a Spark pool for a particular task. Microsoft Fabric supports multiple Spark runtimes and will continue to add support for new runtimes as they're released. You can use the Workspace Settings interface to specify the Spark runtime that is used by the default environment when a Spark pool is started. You can create custom environments in the Microsoft Workspace, enabling you to use specific Spark runtimes, libraries, and configuration settings for different data processing operations. When creating an environment, you can specify the Spark runtime it should use, as well as the Spark pool that the environment should use. You can view the built-in libraries that are installed in every environment. You can install specific public libraries from the Python package index and custom libraries by uploading a package file. You can specify Spark configuration properties to override default behavior and load resource files that need to be available in the environment. After creating at least one custom environment, you can specify it as the default environment in the workspace settings. To edit and run Spark code in Microsoft Fabric, you use notebooks, or you can define a Spark job. You can run Spark in a notebook when you want to use Spark to explore and analyze data interactively. Notebooks enable you to combine text, images, and code written in multiple languages to create an interactive artifact that you can share with others and collaborate. Notebooks consist of one or more cells, each of which can contain markdown formatted content or executable code. You can run code interactively in the notebook and see the results immediately. Notebook cells contain either code or markdown text, but not both. To convert an existing code cell to markdown, select the M. To convert a markdown cell to code, select the / up at the top. Markdown cells include a text toolbar to allow you to format the text and add images. The ability to add markdown cells to a notebook is powerful. It allows you to add explanation about your code, document why certain things are being done, and define what you're trying to achieve. Not only does this feature make a notebook more useful, but it also improves collaboration. Most data engineering and analytics workloads are accomplished using a combination of PySpark, the default language for Microsoft Fabric notebooks, or Spark SQL, but you can also use Scala or Spark R. You can change the default language for a notebook, affecting all code cells, or you can use the magic command in a cell to overwrite the default language for just that one cell. For example, the %% magic command changes the programming language for the cell to Spark SQL. Use the %% PySpark to change the programming language back to PySpark, or use the %% Spark to change the programming language to Scala. Note too that the drop-down menu in the bottom right of the cell can also be used to add a magic command. Remember that the magic commands are case sensitive. Code in a notebook is usually run interactively, either by running individual cells or by calling all cells in the notebook. You can also schedule a notebook to run non-interactively. If you want to use Spark to ingest and transform data as part of an automated process, you can define a Spark job to run a script on demand or based on a schedule. To configure a Spark job, create a Spark job definition in your workspace and specify the script it should run. You can also specify a reference file, for example, a Python code file containing definitions of functions that are used in your script, and a reference to a specific lakehouse containing data that the script processes. You can also specify command line arguments, which enable you to vary the behavior of the script depending on the arguments passed to it. This approach can be useful when the same Spark job will be used in multiple contexts. For example, you could use a single script to load data from files into tables, varying the file path and table name when you run it. You can also define a schedule for a notebook or a Spark job definition to have it run unattended at the specific interval that you'd like. This approach may be useful for simple automated tasks that can be scripted or which are not part of a more complex data ingestion or processing workload. In most production environments, a more manageable solution is to include the notebook or Spark job definition in a pipeline, where it can be integrated into a more complex orchestration solution. When you run code in a notebook or a Spark job definition interactively, the code runs in the security context of the currently logged in user. When you run a notebook using a schedule, the code assumes the identity of the user who created the schedule. When you run a notebook in a pipeline, the code uses the identity of the user who owns the pipeline. Regardless of how the code is run, you must ensure that the identity used in the security context has sufficient permissions to access any resources referenced by the code, including tables or files or in a lakehouse. You can use Fabric Notebook to connect to data held in Azure Blob Storage, an Azure SQL database, or other storage options. By connecting to a data source, you can use the data in analytical processes even though it isn't stored in the Fabric Lakehouse. You can also use Spark code to filter and process the data before loading it into the Lakehouse. And that will enable you to use Spark as a powerful tool here for data ingestion into the Fabric Analytics environment. The sample PySpark shown here connects to data held in Azure Blob Storage, reads data into the data frame, and then displays the data. Note the Azure Blob Storage access info at the top with the blob account name, container, and relative path. Next, see the WASBS protocol is being used to access Azure Blob Storage, pointing to the blob container name where your blob file is stored. It notes a placeholder for the Azure Storage account and the domain for the Azure Blob Storage and the path to a specific blob within the container. This URL can then be used to access or manipulate the blob. This example shows how to connect to data held in our Azure Open Dataset, which doesn't require a SAS token. To connect to your own data, you will need to generate a SAS token and then add it to the code in the appropriate places indicated here in the comments. The next statement includes a placeholder for blob SAS, or shared access signature token, that provides secure access to the blob. The previous example connects to the source data with a SAS token before reading the data into a data frame. Depending on where your data is stored, you might need to use a different authentication type, such as the service principal or OAuth. Lastly, it reads a Parquet file from the Azure Blob Storage into a Spark data frame, and finally displays the data frame. Working with data in a data frame within a notebook combines the interactivity of data exploration, expressive data manipulation capabilities, visualizations, collaborative analysis, iterative development, and documentation in a single environment. Natively, Spark uses a data structure called a Resilient Distributed Dataset, or RDD. But while you can write code that works directly with RDDs, the most commonly used data structure for working with structured data in Spark is a data frame, which is provided as part of the Spark SQL library. Data frames in Spark are similar to those in the ubiquitous Panda Python library, but it is optimized to work in Spark's distributed processing environment. When you load data in a Spark data frame, your schema can either be inferred or explicit. Suppose you have a comma-delimited text file named products.csv, which is a very common format. Notice that it has a header row, which includes the column names product ID, product name, category, and list price. Notice, too, that there are 3 records, each starting with a unique number, 771, 772, 773. Products.csv is located in the Lakehouse Explorer under the Data folder. In a Spark notebook, we are using the following PySpark code to load the products CSV file data into the data frame, or DF, for the path files to data. Format is set to CSV, and the header is set to true, so we can infer the schema from products.csv's file's first row or header and display 3 rows. You can also specify a schema explicitly. In the previous example, the first row of the CSV file contained the column names, and Spark was able to infer the data type of each column from the data it contained. However, you can also specify an explicit schema for the data, which is useful when the column names aren't included in the data file. Notice here that we are importing Python SQL types and functions. We're also using struct type and struct field to list out the fields we'd like to create, along with the respective data types. However, the data frame code at the bottom here is the same as before, except the header equals false. Data frame methods are functions or operations provided by a data frame object, and that allow us to manipulate and analyze data stored in a tabular form. You can use the methods of the data frame class to filter, sort, group, and otherwise manipulate the data it contains. For example, the code here uses the select method to retrieve the product ID and line item total columns from the DF framework containing product data and creates a new data frame, pricelist_DF, which contains the results of the select operation to include only the product ID and line item total columns from the original data frame DF and return only 10 records. You can also chain methods together to perform a series of manipulations that result in a transformed data frame. For example, this code chains select and where methods to create a new data frame containing the product ID and line item total columns, and records where the order quantity is equal to 1 or to a 2. The result of this query is stored in the new data frame bikes_df and is being displayed here, as you can see, with 14 records shown. To group and aggregate data, you can use the group by method with aggregate functions like min, max, count, sum, average, and more. This PySpark code example counts the number of products for each order quantity. It then divides the results in the new data frame counts_df as shown here. You'll often want to use Spark to transform raw data and save the results for further analysis or downstream processing. This code example saves the data frame bikes_df as a Parquet file named bikes.parquet in the path files/product data, replacing any existing files of that same name. Up until now, we have seen many examples using PySpark. However, you can also work with data using Spark SQL. This is because the DataFrame API is part of a Spark library named Spark SQL, which enables data analysts to use SQL expressions to query and manipulate data. We can create database objects in the Spark catalog, which is a metastore for relational data objects such as views and tables. The Spark runtime can also be used with the catalog to seamlessly integrate code written in any Spark-supported language with SQL expressions. Using SQL may be more natural to some data analysts or developers. One of the simplest ways to make data in a data frame available for querying in the Spark catalog is to create a temporary view, which is automatically deleted at the end of the current session. See our example here where we create the products view in the meta store using that create or replace temp view method. You can also create tables using the save as table method to save our data frame DF as a Delta Lake table named products. Products will be persisted in the catalog and can be queried using Spark SQL. Tables are metadata structures that are shown here since there is no explicit path listed for products table to be stored in. It will be stored in the tables folder location as a managed table in our data lake. Managed tables actually handle both data and metadata management. Remember too that deleting a managed table will also delete its underlying data. We've already noted that the data will persist if you save it as a table, but it's also more efficient to query it as a table, as well as being able to share it. The table storage also optimizes for better compression and performance and can be partitioned and indexed for improved query performance. Managed tables are also better suited for long-term storage and querying. By contrast, remember that data frames are ideal for data processing and transformation tasks and are purely in-memory structures. So the decision to create a view only available in this current session or save a data frame as a new table, which is persisted, is really based on whether or not you want to reuse it. Please note that if you need to create an empty table, you can use the spark.catalog.createTable method. Create an external table as shown here is to write a data frame DF to a Delta table and to save it as an external table in a specified location. In this case, it will be saved in the path off of the files and named My External Table. An external table is a table in a database that is stored outside the database itself, typically in an external storage system like a file system or a cloud storage. External tables allow you to query and analyze data without importing its data into the database, providing flexibility in data management. This is useful for integrating large data sets stored externally with your database operations. You can use the Spark SQL API in code written in any language to query data in the catalog. This is a PySpark code snippet that contains SQL code to query the fields product ID, product name, and list price from the products table, where the category field is equal to mountain bikes or road bikes. This code uses a SQL query to return data from the products table as the data frame bikes_df. Here is the SQL code snippet that can be used in a notebook. Simply use the %% magic command with SQL to run SQL code that queries objects in the catalog. Here we are querying the catalog field and then counting the product ID field and making a new field called product count in our results set, all from the products table, by grouping and by ordering by category. The results will count the number of products by category. One of the most intuitive ways to analyze the result of data queries is to visualize them as charts. Notebooks in Microsoft Fabric provide some basic charting capabilities in the user interface, and when that functionality doesn't provide what you need, you can use one of the many Python graphic libraries to create and display data to visualize in your notebook. You can use built-in notebook charts. When you display a data frame or you run a SQL query in a Spark notebook, the results are displayed under the code cell. By default, the results are rendered as a table, but you can also change the results view to a chart and use the chart properties to customize how the chart visualizes the data. You may also want to use graphic packages in code. This example uses matplotlib, but you can also use Seaborn and many others to enhance visualization. Most are built on the base of the matplotlib library and are rendered in a notebook, making it easy to combine code to ingest and manipulate data with inline data visualizations and markdown cells to provide commentary. Now let's take a look at how to analyze data with Apache Spark.
Welcome to our lab number 2. And in lab 2, we are going to be working with analyzing data with Apache Spark in Fabric. So like we begin every lab, we're going to start off first by creating a workspace. And this workspace can have really any name you want to give it. I'm going to call this DP700 Lab 2. And most important, we need to make certain that it has either the trial license or Fabric capacity. And I'm going to go ahead and apply this. Once that workspace is created, notice it has nothing inside of it. But we're going to make a lakehouse to start off with. So I'm going to click on New Item. And inside New Item, I'm going to go down and select Lakehouse. And again, you can give your lakehouse any name you'd like, but I'm going to keep these kind of together with the same name. So I'm going to create this lakehouse, and we're going to do some notebook work inside of it in just a moment here. Now, once the lakehouse is created, we do have some lab files that you can use, and it should be off of this link right here. So this link right here will download a zipped folder called orders. And if you unzip that folder, it will create the orders folder, plus it will have 3 files inside: 2019.csv, 2020.csv, and 2021.csv. So you'll want to make certain that you download those and unzip it. Then what we're going to do is we're going to go ahead and upload this time into Files, a folder, and we're going to go find that folder that we just downloaded. And it is in here, as you can see. There's orders. And I'm going to go ahead and upload it right now. That will download those 3 files. And I'll be able to see those 3 files here under orders. So there is the 2019 CSV, and if I click on it, you can see the CSV file. So it has many records in it. You can see the same thing with 2020 CSV, little preview, a lot of records in there. And then same thing with 2021. So they're all CSV files. And each of those files, as we talked about in our last lab, we could go in and we could load them to a table, make a new Delta table out of them if we wanted to do that. But what we're going to do is we're going to do in this section a little bit different, since we're going to try to work here with some Apache Spark capabilities. So we're going to work with a notebook. And I'm going to create a new notebook right here. And that will open up the notebook here inside of our Lakehouse. And there is our Lakehouse right here. I'll click on it to open it up. It might take it a moment to kind of refresh itself, but we'll see the tables and files there shortly. And what we're looking at is we're looking at our code cell. And the code cell actually has some notes in it. So we could change that out to maybe a markdown cell. It has a little bit of a different look to it, little here are formatting and text. So we could keep that. And then what we're going to do is we could edit this. We could change it back to a code cell. Notice you can go back and forth with that. But we have a number of options here. We're going to mainly be working with code cells going forward. And what we'd like to do first is we'd like to create a data frame. So to make that data frame, what we're going to do is we are going to go in and we're going to take some of our existing files here, in particular 2019 CSV, or any one of these would work, honestly. And we're going to go ahead and load data as Spark. So this is going to give us the code to be able to create a data frame from this CSV file in Spark. Notice too that we're telling it there is a header, and then we want it to display the data frame. So I'm going to go ahead and run that. And when I run that, you can see the results there eventually that it will show. Now, since this is the first time I'm running it, it's going to have to start the Spark session. So it takes it a little bit of time to start that session. Looks like it started about 4 seconds or so. So it's taking a little bit to show, but then you can see the result. So this is that 2019 CSV in more of a table view. If you can see, we can notice that right here. It's a table view. So this works out for us. But as you look a little closer to this, you may discover that the fields up at the top have kind of the name of that first record. So it looks as though we didn't have a header there. So what we can do is we can modify that first line and say, you know what? We don't have a header. So let's rerun this, but rerun it with the fact that we don't have a header. Now, I could just click on, actually I might do that. I could type the word false here. Let's try that. It's going to replace the whole line, but I'm going to try to just type the word false. And then let's rerun this and see what happens. So if we don't have a header, what does it do? Well, it kind of does this. See how we don't have a header because that first line isn't really a header, but notice the header that it gives it. C0, C1, C2, C3. I don't know if this is any better. So what we're going to do is we're going to make a little bit of a change to this. And we're going to work with some of our PySpark SQL options here, types here. And I'm going to do this a little bit differently here. I'm going to go in and open up a new code cell. And you saw how I did that. I just hovered under the results of the last one to click that. And I'm going to paste in some of this syntax here that might be helpful. And this is to give our fields names, set them up with data types. We are using some of our PySpark SQL types here to make that happen. So that looks a little bit nicer. So you can adjust the schema as you see with that. So we have names of fields and their data types here. So that comes in handy. We could also go in and do a little modification to this. So what we've been doing so far is picking up just 2019 CSV, but we can use wildcards here. So what I'm going to do is I'm going to use a wildcard with that CSV extension there. I want to keep the old one so we can compare it if we want to do that. And I'm going to go ahead and use this example here where we're using the asterisk in front of the .csv. So I'm going to ask it for all of our CSV files. Now remember, it only is going to show us the top 1,000, but now we have a longer list here that not only shows 2019 if we dig really far down, but it should show 2019, 2020, and 2021. So I'd have to expand those rows quite a lot because these are very big table files. So you can see we can include a wildcard there with our asterisk next to the CSV. So that gives us a little bit more, bigger example of things we can do, and wildcards can be used throughout as we'll take note. The other thing I'll note here is I would like to do a little bit of filtering of this data frame here. And I'm going to do it by creating a new data frame called customers. And what I want to do is I really just want to extract the customer name and the email for this new data frame. So I'm going to go ahead and execute that. And now we should only have 2 fields returned. And we're going to have it count the distinct options too. So you can see a little bit of what we get with this. So we have it count and distinct. They're used here to provide totals for the total number of customers, and then our unique count here, as we can see. So we're just seeing the uniqueness there. So one of our emails there, so counting customers and distinct. So if there's any duplicate customers, we're only coming up with the with one of them. So you can see that. And then what we're going to do is we're going to modify this a little bit more because this still might be a very large list. So we're going to try to use a little bit of SQL in here using 2 functions, select and where. So these should be fairly familiar. And we'll add that in there. And we're going to have it select customer name and email where the item is equal to, and you can see very SQL-esque here. But now we have a little bit more of a narrow list. 133 records are returned with this. So it's just focusing in on that where clause there. So we're filtering out. So some SQL-esque commands there. Then what we want to do is we want to do a little bit of aggregation. So I'm going to come in here. I'm going to click on code. We'll open up a new cell there. And we'll do a little bit of aggregation using select and group by. So you can use that here. And with our product sales data frame, we're going to select item and quantity and group by item. So we're going to see the sum aggregate function applied to our numeric column, in this case, quantity. So we can see that there. So we have the group by method. It's grouping rows by item and then aggregating quantity. So that gives us a little look there. at working with select and group by. A lot of good options you can choose in here for functions. But what we'd like to do too is we'd like to do another statement here, physically working with the Spark SQL functions. We're going to import those in with that statement at the top right there. Then we are going to have it select, and using that method, it's going to use the SQL year function, and it's going to extract the year component of order date. And it's going to put it into a new field called year, and you can see that with alias year. And then we're going to have it group by year, and then count, and then order by year. So, and then we'll have it display that yearly sales data frame. So we'll go ahead and execute that. And then there you can see the data frame that's returned there, where it's going in and it's counting, it's showing the years and then doing a count of the orders. So it's doing it by order date. So that looks good. So you have a lot of ways to work with this, working with SQL functions here, using, of course, our SQL-esque methods that are available in PySpark. So a lot of ways to work with it here that might be helpful. I'm going to scroll and talk a little bit more about using data frame methods and functions to do transformations. So that's another option. I could take some of these methods and functions and use it to transform data. So in this example here, what we're going to do is we want to create a month and year column based on the order date. And let me execute this so you can kind of see what I'm talking about. I also want to create the first and last name field from the customer name field. And then I'm going to create, I want the fields to be ordered in this order right here. So here is the year field and the month field that was created. And you can see the we're using that with column option there to kind of create some of these options for us. And the year portion is being extracted from the order date, and then the month portion from order date is being extracted. So that's how we're creating those two fields there, is from extracting from order date. And then you have the first name field and the last name field, which were not there initially, but now we have them because we took the customer name, and what we did is we split it out. We split out the first name and last name from the customer name field, and then we did not include it in our result set. And as a matter of fact, we have the result set showing sales order number, sales order line number, order date, year, month, and you can see the order that we're going in with this. So this gives us a little bit more control here. You can do some transformations, so some data frame methods for that purpose. You might find those very helpful. Now, what we might want to do at this point is maybe save that transformed data frame and maybe save it into, let's say, the Parquet format. And if we decide to do that, we have to tell it where we'd like to store it. So we are going to write and overwrite this, and you can see Parquet format there. And we're going to put it under Files, and then there's going to be a folder created called Transform Data, and then another one called Orders that we will add to this. And then we want it to tell us that it's been saved. Transform data has been saved. So we want to know that. And then we can also load data. So before we load data here, let me add that code in here to load the data. But let's check to see that these have been created. So there's the files. There, if we refresh it, and it may take a little bit, but it should hopefully refresh. I was trying to stall a little bit so we could get it refreshed there. There's transform data. So that's what we had created here. And then here's orders right below it. And then inside orders, you can see our file. That's our transformed data frame. Some of its data, it's very large, the data that it stores inside of it. So it created a number of files. And then what we'd like to do is we'd like to load a little bit more into this. So what we're going to do is we're going to go ahead and run this load statement right here. And what you'll get to see with that is this data frame here is going to give us a little bit more information. It's going to load data into those files for us. And you can see some of the data that it has added here, and it's giving us a little view of it, of what it added in. So we loaded a little bit more into orders there. Okay, so you can see a little bit of our process. We also can go in, and since we have a lot of data, what we might want to do is partition our data. So what you can do is break the data up, and maybe we want to break it up based on time. That's a very common way of breaking it up. So maybe what we want to do is have it partitioned by year and then by month. And we want to put it off of files, but then make another folder in there called partitioned data. So I'm going to go ahead and execute that. And when I do that, it's going to take it a minute or so to run here. Once it runs, then what we can do is we can see if we can see it. So I'm going to go up to Files and refresh, and we may see it come out right there. There it is right there. Partition data. So it's taking it a little bit, but you can see we have a partition there by year. And then if we go, let's say, into one of the years, you can see the months broken out there. So we have the partitions created by year and then by month. And so that's an easy way to do it here, is to do your partitions when you have a very large data set. This will help with performance. Breaking it into usually how you query for the data is helpful. So we have that. So you can see that option there. And then what we can do is we can turn around and we can load data into those partitions. So we'll go ahead and do a little loading to year 2021, and the month is set to a wildcard. And then we're going to display what we are loading into that data frame there. So you can see that. And then if I go out to some of these months, you might also be able to see that there's Parquet files inside. So this section hopefully is a little helpful, giving you an idea of how to work a little bit more here with some of our Parquet files, partitioning for performance. We always have to think about performance. That's going to be very critical. Now, the other thing we can do is we could just have it make tables for us. Now, you saw how we made tables before. We were able to go to our CSV files and we could load it directly, making a table that way. But you could also do it through your notebook. So I'm going to go ahead and add in the code here. And we have the code to create this new table. It's going to be a Delta table. It's going to be called Sales Orders. And it will be available here under Tables once this runs. We also asked it to give us information about that sales order table, which is describe extended. That's the function that we're using there to give us that detail. So down here, it's telling you a little bit about it, the fields that are involved, the data type. You can find out a little bit more about its location, the owner, the table properties a bit here. But I could also click on tables, might have to refresh it, and we should see our sales order table right there. So that's what we did. We made a Delta table using our Spark here inside of a notebook. So there's a lot of ways to make tables, as you could see. This could be a good option. We might also want to take this a step further. And maybe what we want to do now is we want to maybe load that table. So we can do that too. We created the table. Now we're going to load it with some data. Select asterisk from our Lakehouse. And we're going to push this into sales orders so we could load it very easily with that. So that's an option here. I could paste it in like that. I could put my Lakehouse in. The other way I can do this is I can go to our menu there and load data from it. So I could have done it this way or the way I just showed. So there's two ways to do it. The way I just showed was probably the better and easier option, but this is another way that I can go in and set this up. So I could run this also. Okay, so you have a lot of ways to make this happen and create that sales order, use that sales order table there. A lot of ways to do it. Okay. Now I'm going to run a little query against sales orders here. And we're going to see what's currently inside of it. And there it is right there. So this is showing you a little query against sales orders. And you can see I'm using, in this case, the magic command. So you have the 2% symbols with SQL next to it. So that's the magic command where I can change out the language. And instead of using maybe PySpark, I want to use SQL. So I could use, change that language to a SQL Spark here. I could choose other languages also that work here with our notebook. And then you can see too that we're querying that sales order table that we have there in our tables folder. And we can see the output there where we're having it select the, go into the order date and pull out the year portion of the order date and put that in the field order year. And then sum unit price times quantity plus tax. And we're going to call that gross revenue. And then we're going to have it grouped by order date and ordered by order year. So you can run that statement, typical SQL statement there that we can use. So a lot of ways to get information. As you can see, it just depends on what language you feel more comfortable with. And you can do some variation here as we're showing. Now, what we want to do too is we want to show another query. Just kind of a basic query here, where we're just going to query for everything in our sales order table here. It's going to take it a moment, and you can see the result. So, we had a couple queries against it. This is kind of a general query against it. But what we want to do is we want to change things up a little bit. And instead of seeing the results in a table, we'd like to see it in a chart. So you have the visualization that you can do here. You could also, of course, if we had our sales order table right there, we could use that in our SQL endpoint, and we could go in and do the report in Power BI. But from here, you can see what it's going to create, and you can also see some other examples. So you can choose one of the suggestions here. You could edit what this currently is doing. You could also build your own. So I'm going to go into build your own, and I'm going to make this, there's a lot to choose from in here, but I'm going to keep it a bar chart there. I'm also going to go in and I'm going to set, I could put a title on it. I'm going to set the x-axis to item. I'm going to set the y-axis to quantity. And then it looks pretty good here the way it is, honestly. This isn't bad. You could go with this chart. Maybe you want to switch it out to something else, but this doesn't look too bad. So I could create this, but this might not be the ideal option. There's other ways we can visualize. So other ways to visualize, I could use matplotlib. And this is one of the libraries that is available to us. So I'm going to go into code, and I'm going to first run a statement here. And you're going to see how it runs first. So you can see the SQL statement in there that we're trying to run with our SQL query. And you can see the result. May not be the best to see, when you work with the data frame, the result might not be the best. But what if we took it a step further, and what we did was we got into our matplotlib library and imported that. It does require pandas, so you can kind of see we're calling pandas there also. And maybe what we do is create something like this. So that's not a bad option. We could also take it a step further and get very detailed with it. Although this is a lot of code, we could use the matplotlib here to give our chart a title, to say what we want plotted, x-axis, y-axis, the height on this, the color. We could give it labels for the different x and y axes there that we can say what kind of grid. So you can get a lot more detailed with it with matplotlib. So these might be good options for us, but it does require a lot of code. But you can get pretty nitty-gritty with it. And I might even make another option with this. So you can do this a couple different ways. But maybe what you want to do is you want to maybe change this out a little bit, although there's a lot in here that we can use to create. We can make pie charts and all that. But maybe what we want to try to do is use something that might be a little simpler syntax-wise and maybe still give us enough bang for our buck. And that is maybe working with Seaborn. Notice the syntax is pretty simplistic. And let's see the result that we get from this. And this one isn't too bad here. That one actually looks pretty nice. And it was very simplistic syntax to make this happen. So I think that's all the better, honestly. So that's an option. Let's see another Seaborn option out here that we could work with. This is a little more detail that we could give it for a bar chart. It's going to have a white grid on it. So you have some options. You can use the ones that are built in here if you'd like. We had the ability to do a chart off of some of our options there when we ran the cell. And then you could also, of course, use Power BI. And then if you'd like, you could take a dip into Seaborn or even Matplotlib as an option. Okay, so I'm hoping this was helpful. And I'm hoping to also see you in our next section.
In this section, we discussed how Apache Spark is integrated into Fabric, along with how to prepare to use it and configure it. We explored how to ingest, transform, and load data into a lakehouse using Apache Spark notebooks with both PySpark and Spark SQL. We discussed creating views, tables, and data frames. We also showed how to visualize data using built-in notebook charts and other integrated graphics packages. This concludes part 1. Let's recap all the content we've covered. In this section, we discussed how Apache Spark is integrated into Fabric, along with how to prepare to use it and configure it. We explored how to ingest, transform, and load data into a lakehouse using Apache Spark notebooks with both PySpark and Spark SQL. We discussed creating views, tables, and data frames. We also showed how to visualize data using built-in notebook charts and other integrated graphics packages. Thank you for joining us so far. We look forward to seeing you in part 2 of the Microsoft Azure Virtual Training Day, Implement a Lakehouse with Microsoft Fabric.